chapter 25, we investigate the relationship between two qualitative variables or two categorical variables using contingency table or chi-square test. I'm going to go to File, Load, Chapter 25, and I'm going to choose example 7. In this example, we will see two categorical variables. One is the living situation, another is phone service. We have 1, 2, 3, 4, and 5 different living situations. And we have two different phone service, means we have two categories. And we have count here. Count means there are 165, for example, observations who have landline sample and they live with their parents. So we want to see the relationship between these two. In contingency table, we have counts. So there's one thing actually before I show you the contingency table, I want to explain that there is a null hypothesis, an alternative hypothesis for testing the independency between these two variables, two categorical variables. So the null hypothesis says there is no relationship between these two categorical variables. And then alternative will say there is a relationship between these two categorical variables. So keep that in mind. We are going to use contingency table to test and analyze these hypotheses. We are going to go to statistic, contingency table with count. We are going to use phone service as a row variable and living situation as a column variable. So how I'm choosing this? Normally, if we know which variable is dependent variable, which variable is independent variable, we can say the explanatory variable or independent variable goes in row and the dependent variable goes in column. But in this case, just think about that. We are just investigating the relationship between these two variables, right? Maybe both of them are independent variable. We want to just see if there is a relation between these two. So doesn't matter which one goes to row and which one goes in column, but I'm going to choose living situation as a column variable. Why? Because it has more categories, and if I calculate this, you will see it gives a really beautiful and more clear table to us. So we are going to choose count here and then calculate, and as you see, as I said, columns are now living situation and there are 5 columns. If I was choosing a living situation to be in row, I would have 5 row in this way. Okay, so we will see the total here. This is the whole number of individual, which means if you add all the counts together, you should get 459. And then the first numbers in these cells are the counts that you saw here in the last column. If you add all of them in a row, you will get 329. If you add all of this first number in this second row, you will get 130. If you add 329 to 130, you will get 459. And then the same way you can add 7, 15, which gives you 22. Means you're adding the column count to get a total in each column. Okay, so what is the second numbers in each cell? Actually, the information is here. It says percent of row. Means if you divide 7 by 329, which is the total in this row, you should get 2.128. If you divide 16 by 329, you should get 4.86. And then the next number is percent of column, means this one. So how we get 31.82? If I divide 7 by 22, which is the column total, I will get 31.82. What is the next one? Percent of total, means if I divide 7 by 459, which is the total. Okay, so these are the numbers and values you see in this table. So now this is the value of chi-square test. You have the formula and you know how to calculate this from the note. Degree of freedom is the number of column minus 1 multiply the number of row minus 1. Means if I have 5 column, 5 minus 1 is 4. If I have 2 rows, 2 minus 1 is 1. So 4 multiplies to 1 gives us the degree of freedom. Then we have the p-value, and this probability here is calculated to be very, very small, very, very less than the level of significance. And actually now I didn't provide any level of significance for you, but it's obvious that the number is very, very small. This p-value is very, very small, so we don't have to have the level of significance at all. So if we have the p-value and we know the p-value is very small, we say we can reject the null hypothesis. And you should remember what was the null hypothesis. Null hypothesis says there is no relationship between these two categorical variables. So if we are rejecting that, means there is a relation between the living situation and phone service. So the other situation could be a big p-value, a large p-value, and in that situation we would say we cannot reject the null hypothesis. Means there's no relationship between these two variables.